Welcome to the third section of our course, Scheduling and Resource Management. In this session, we will focus on how to effectively schedule project activities and manage resources to ensure project success. Project scheduling is not just about listing tasks. It is about structuring them in a logical, efficient sequence to optimize productivity and minimize bottlenecks. Likewise, resource management involves ensuring that the right resources are available at the right time to execute the plan successfully. Why is scheduling and resource management critical? In any project, time and resources are two of the most valuable assets. Poorly managed schedules lead to delays, cost overruns, and inefficiencies, while poor resource management results in wasted budget, burnout, and missed deadlines. Effective scheduling ensures that activities are carried out in the right order, at the right time, and by the right people. Meanwhile, resource management ensures that the necessary human, financial, material, and technological resources are allocated optimally. Consider the following scenarios. A software development team works on a new feature, but they realize late in the process that the required APIs were not available at the start. As a result, time is wasted and deadlines are pushed back. A construction project lacks proper scheduling, causing workers to arrive before materials are available, leading to wasted labor hours and increased costs. A project manager does not track resource utilization properly, leading to overworked team members, burnout, and an eventual drop in productivity. What we will cover in this section. By the end of this section, you will understand how to effectively schedule tasks and activities to improve project efficiency, how to manage dependencies and milestones to ensure smooth workflow progression, how to allocate and balance resources to prevent bottlenecks and overloads, common scheduling and resource management pitfalls and how to avoid them. How does scheduling fit into project management? Scheduling is a key part of the project planning and execution phases of the project lifecycle. A well-developed schedule ensures that project activities are executed in a logical order, minimizing conflicts, redundancies, and delays. Key scheduling benefits. Clear task dependencies ensures tasks are performed in the right sequence. Efficient resource utilization prevents wasted labor and material. Predictability helps estimate completion timelines accurately. Risk mitigation reduces potential conflicts by forecasting delays and bottlenecks. Stakeholder communication provides a structured timeline to keep stakeholders informed. For instance, in a product launch, scheduling ensures that marketing campaigns, prototype development, and logistics all align, avoiding mismatches between demand and product availability. The role of resource management in project success. Projects require multiple types of resources to function effectively, including human resources, project managers, team members, subject matter experts, material resources, equipment, raw materials, office supplies, financial resources, project budget, funding sources, technology and tools, software, communication tools, project tracking systems. Resource management challenges. Many projects fail due to poor resource allocation. Some common issues include resource overallocation, assigning too much work to a limited team, underutilization, not using available resources effectively, skill mismatch, assigning tasks to individuals who lack expertise, budget misalignment, poor planning leading to cost overruns. For example, if a construction project does not allocate cranes and scaffolding in advance, teams might be forced to delay work until they become available. Similarly, in a software project, failing to plan for necessary software licenses in advance can halt development progress. Best practices in scheduling and resource management. 1. Use scheduling tools and techniques. Effective scheduling requires using tools like Gantt charts, critical path method, CPM, and work breakdown structures, WBS, to visualize timelines and dependencies. 2. Prioritize tasks based on criticality. Not all tasks are equal. Critical path activities must be prioritized, as they directly impact project completion timelines. 3. Balance workloads to avoid burnout. Overburdening key team members leads to burnout and inefficiencies. Ensure that workloads are evenly distributed across resources. 4. Monitor and adjust as needed. Schedules and resource plans should be dynamic, adapting to changes as projects evolve. Continuous monitoring helps identify issues early. Common pitfalls to avoid. While scheduling and resource management are crucial for project success, common mistakes can lead to inefficiencies. Here are some pitfalls to avoid. 1. Ignoring task dependencies. Failure to establish dependencies between tasks can lead to significant workflow disruptions. For example, design approval must come before development, or else developers might work with outdated specifications. 2. Overscheduling key resources. Assigning the same individual to multiple high-priority tasks simultaneously leads to delays and exhaustion. Proper resource allocation ensures that workloads are reasonable and sustainable. 3. Failing to build contingency buffers. Unexpected delays are inevitable. Not including buffer time in the schedule makes it harder to adjust for unforeseen issues, such as supplier delays, unexpected rework, or regulatory approvals. 4. Poor stakeholder communication. Project timelines should be shared with all stakeholders. If teams are unaware of schedules, they may not be prepared when their tasks begin, leading to missed deadlines and inefficiencies. Looking ahead. In the next slides, we will explore task dependencies and milestones in greater detail, showing how different activities interact and how setting clear checkpoints helps keep projects on track. By mastering scheduling and resource management, project teams can enhance efficiency, avoid unnecessary costs, and deliver successful project outcomes. Let's move forward. Scheduling is more than just listing tasks. It involves understanding the relationships between activities, known as dependencies. Dependencies define the logical sequence in which tasks must be executed. By mapping dependencies, project managers can create schedules that reflect the real-world constraints of the project. The role of dependencies in project scheduling. Dependencies establish the flow of work in a project, ensuring that tasks are performed in a logical and efficient order. Without properly defining dependencies, teams may encounter delays due to missing prerequisites. Tasks may be started prematurely, requiring rework. Bottlenecks caused by poor sequencing. Some teams may be waiting for others to complete their work. Resource misallocation. Teams may not be available when needed if dependencies are unclear. A well-structured dependency map helps mitigate these issues and ensures that work progresses smoothly. Types of dependencies. There are 4 main types of task dependencies that dictate how activities interact within a project schedule. 1. Finish to start, FS, the most common dependency. Definition. Task B cannot start until Task A is completed. Example. In software development, testing, Task B cannot begin until coding, Task A, is complete. Why it matters. Ensures that prerequisite work is finished before dependent work starts, reducing errors and inefficiencies. 2. Start to start, SS, simultaneous start. Definition. Task B cannot start until Task A starts. Example. In construction, pouring concrete, Task A, and smoothing the surface, Task B, must begin at the same time. Why it matters. Helps optimize schedules where parallel work can occur to reduce project duration. 3. Finish to finish, FF, simultaneous completion. Definition. Task B cannot finish until Task A finishes. Example. A marketing campaign, Task A, and product launch, Task B, must both be completed at the same time. Why it matters. Synchronizes dependent tasks that must conclude together to avoid misalignment. 4. Start to finish, SF, the least common dependency. Definition. Task B cannot finish until Task A starts. Example. In a hospital shift change, the next nurse, Task A, must start before the current nurse, Task B, can finish their shift. Why it matters. Ensures continuity in operations where overlapping responsibilities are necessary. The importance of dependencies in project execution. Dependencies play a critical role in project success by ensuring logical sequencing. Activities follow a structured and optimized order. Efficiency in task execution, minimizing idle time between tasks. Better resource allocation, prevents resource conflicts and shortages. Proactive risk mitigation, identifies potential bottlenecks before they cause delays. Example, dependency mismanagement in a construction project. Imagine a home building project where plumbing installation, Task A, must be completed before drywall installation. Task B. If drywall is installed prematurely, workers may have to tear it down to access plumbing, leading to costly rework and delays. Properly sequencing dependencies prevents such avoidable mistakes. Milestones, key checkpoints in project timelines. Milestones serve as progress markers within a project. Unlike tasks, milestones do not consume time or resources. Instead, they indicate major accomplishments and key decision points. Characteristics of milestones. Fixed points in time. No duration, only a marker. Tied to deliverables, indicate completion of significant project phases. Review and approval points signal when stakeholders need to assess progress. Examples of milestones. Project kickoff completed. Official start of the project. Completion of requirements gathering. Business and technical needs are documented. Prototype development finished. First working model completed. Testing phase concluded. Product successfully passes quality assurance tests. Project closure and final sign-off. Formal acceptance by stakeholders. Example: milestones in an event planning project. For an international conference, major milestones could be securing the venue 6 months before the event, finalizing speaker lineup 4 months before the event, marketing launch date 3 months before the event, event execution, conference start date, post-event evaluation 1 week after event conclusion. Common scheduling pitfalls and how to avoid them. While dependencies and milestones improve project scheduling, teams often encounter common pitfalls that disrupt timelines. Below are key challenges and solutions. 1. Ignoring dependencies, leading to task conflicts. Issue: overlapping tasks without clear sequencing cause workflow disruptions. Solution: use Gantt charts or dependency mapping tools to visually track relationships between activities. 2. Poorly defined milestones, making progress hard to measure. Issue: setting vague milestones that do not reflect real achievements. Solution: ensure each milestone aligns with specific deliverables and project goals. 3. Overloading critical path activities, causing delays. Issue: too many tasks on the critical path increases project risk. Solution: distribute workload evenly and build in time buffers for unforeseen issues. 4. Not accounting for resource constraints, leading to overburdened teams. Issue: scheduling conflicts when key personnel are overassigned. Solution: balance resource allocation based on availability and workload capacity. 5. Failing to adjust schedules as projects evolve. Issue: sticking to rigid schedules even when conditions change. Solution: continuously review and update schedules to reflect real-time project progress. Final thoughts and looking ahead. Project scheduling is a dynamic process that requires careful planning, dependency mapping, and milestone tracking. By applying the principles covered in this section, teams can enhance productivity by ensuring tasks flow smoothly, improve risk management by anticipating scheduling conflicts, optimize resource utilization for efficient project execution. In the next section, we'll dive deeper into resource allocation strategies, where we'll explore techniques for optimizing workforce distribution, avoiding bottlenecks, and maximizing project efficiency. The critical path method, CPM, is one of the most essential scheduling techniques in project management. It provides a systematic approach to identifying and managing the longest sequence of dependent tasks that dictate the shortest possible completion time for a project. By applying CPM, project managers can determine which activities directly impact the project schedule and which ones have flexibility. Understanding the critical path helps in making informed decisions regarding resource allocation, schedule adjustments, and risk mitigation. In this section, we will walk through the fundamental steps of determining the critical path and explore its significance in keeping projects on track. What is the critical path? The critical path is the longest sequence of dependent activities in a project. Any delay in this path will result in a delay in the overall project completion. Think of the critical path as the backbone of your project timeline, a chain of tasks that must be completed in a specific order for the project to finish on time. If any task on this path is delayed, the entire project will be delayed unless corrective actions are taken. A project schedule consists of critical tasks and non-critical tasks. Critical tasks have zero float, meaning they must be completed on time to avoid delays. Non-critical tasks have some flexibility, meaning they can be delayed without impacting the project's final completion date. Key benefits of CPM. Applying the critical path method to a project helps in identifying essential tasks, allows managers to focus on the most time-sensitive activities. Optimizing scheduling ensures resources are allocated efficiently. Improving risk management identifies bottlenecks early. Enhancing project control helps teams track progress more effectively. Reducing delays allows managers to take proactive corrective actions when necessary. Now, let's go through the step-by-step process of determining the critical path without software tools. Step 1. List all activities required to complete the project. The first step in CPM is to create a comprehensive list of tasks that are required to complete the project. This list should include every individual activity that contributes to project success. Each task should be specific, measurable, and actionable. The more detailed and structured your activity list is, the easier it will be to determine dependencies and estimate durations accurately. Example: website development project. Imagine you're developing a website. First, the designers create the user interface, ensuring a seamless experience. Once that's finalized, back-end developers start building the server-side functions. At the same time, front-end developers integrate those features into the website's layout. Finally, the testing team ensures everything runs smoothly before launch. Now, the critical path here would be the longest sequence of tasks that must be completed in order, without delay. Step 2. Identify dependencies between activities. Once we have a task list, the next step is to determine how each task relates to others. Task dependencies help structure the logical sequence in which work should be completed. Example: software development workflow. Let's consider a software development project. The process typically begins with gathering requirements, followed by designing the system architecture. Once the design is complete, the development phase begins, where the actual coding takes place. After that, testing is conducted to ensure functionality, and finally, the product is deployed to the users. If testing is delayed, deployment will also be delayed. Step 3. Estimate the duration of each activity. With dependencies in place, the next step is to determine how long each task will take. Estimating durations accurately is essential to forecast project completion dates. Example: website development task durations. A typical website development timeline consists of 4 key phases. First, the UI and UX design takes about 10 days. Once the design is finalized, the back-end development begins, requiring approximately 20 days. The front-end integration phase follows, which takes around 15 days. Lastly, testing is conducted over a period of 12 days to ensure quality before the website is ready to launch. Step 4. Create a network diagram to visualize task sequences. A network diagram is a flowchart that represents task sequences and dependencies. Example: project task flow. Let's visualize this using a simplified approach. Imagine the project starts with task A, followed by task B, which leads to task C, and ultimately ends at task D. In a real-world scenario, these tasks would be connected based on their dependencies, ensuring that each step follows logically. Step 5. Determine the longest path through the network. This is the critical path. To determine the critical path, identify the longest sequence of dependent tasks from project start to finish. Example: office relocation. Imagine you are managing an office relocation. First, packing is completed before moving equipment. Once equipment is moved, the IT setup begins. Only after IT setup is completed can the office officially open. If IT setup is delayed, the office opening will also be delayed. In this case, the sequence from packing to office opening is the critical path. Managing the critical path. Monitor critical tasks closely. Any delay impacts project deadlines. Fast-track tasks. Execute some activities in parallel if possible. Allocate additional resources. Assign more personnel to accelerate progress. Final thoughts. Understanding and managing the critical path method, CPM, allows project managers to Optimize workflow sequencing. Anticipate scheduling risks. Ensure on-time project delivery. By mastering CPM, teams can effectively plan, track, and adjust schedules without relying on complex software tools. Next, we will explore how to balance resources effectively to enhance project efficiency. Resource allocation is a fundamental aspect of project management. It involves assigning the right people, equipment, and materials to the right tasks at the right time, ensuring the efficient use of resources while maintaining project deadlines. Proper resource allocation prevents bottlenecks, burnout, and project overruns, helping teams stay productive and ensuring smooth project execution. Effective resource allocation is not just about assigning tasks. It also requires strategic planning, monitoring, and realignment as the project progresses. Resources include human resources, team members and stakeholders, financial resources, budget, funding, material resources, equipment, materials, and technological resources, software tools. Why is resource allocation important? Proper resource allocation ensures that project deadlines are met without delays, ensuring that key personnel and materials are available at the right time. Workloads are balanced, preventing team members from being overwhelmed or underutilized. Costs remain under control, avoiding unnecessary expenditures due to resource shortages or inefficiencies. Productivity is maximized, ensuring that the team operates efficiently. Risks are mitigated, identifying potential resource shortages and adjusting early to avoid disruptions. Imagine managing a construction project where cement deliveries are delayed, or skilled labor is assigned to multiple overlapping tasks. Without proper resource allocation, these situations would cause significant delays and cost overruns. Now, let's explore some of the key strategies for effective resource allocation in project management. Key strategies for resource allocation. 1. Resource leveling, adjusting the project schedule to address resource constraints. Resource leveling is a technique that modifies the project timeline to resolve resource conflicts. This means that if a particular resource is overbooked, project tasks may be rescheduled or extended to maintain a realistic workload. Example: software development project. Imagine a team working on software development. If one developer is assigned to multiple tasks at the same time, resource leveling would adjust deadlines or redistribute work to avoid overloading that team member. While this might extend the project duration, it ensures that resources are used efficiently. When to use resource leveling. When resources are overallocated and cannot handle multiple tasks simultaneously. When the project schedule can be adjusted without harming final deadlines. When workload balancing is necessary to prevent burnout. 2. Resource smoothing. Optimizing resource allocation without affecting the critical path. Unlike resource leveling, resource smoothing ensures that critical tasks are not delayed. It adjusts non-critical tasks so that resource utilization is balanced while staying within the project timeline. Example: marketing campaign launch. A company is launching a new product with a strict deadline. Resource smoothing would reallocate staff working on non-critical marketing tasks to priority activities such as campaign planning, ensuring deadlines are met without disrupting the overall project schedule. When to use resource smoothing. When critical tasks cannot be delayed due to strict deadlines. When there are fluctuations in resource availability that need adjustment. When optimizing workload without extending project duration. 3. Prioritization. Allocating resources to critical tasks first. Prioritization ensures that critical tasks receive the necessary resources first, and then resources are allocated to less critical tasks. Example: event planning. Imagine planning a large corporate event. The critical tasks, such as securing the venue, hiring keynote speakers, and setting up technology, must be completed before focusing on decorative elements or promotional materials. Prioritization ensures that essential tasks receive attention first. When to use prioritization. When resource shortages exist and high-priority tasks must be completed first. When certain project activities have fixed deadlines and others are flexible. When unexpected challenges arise, requiring resources to be shifted to critical areas. Balancing resources, an ongoing process. Resource allocation is not a one-time action. It is a continuous process that requires monitoring and adjustments throughout the project lifecycle. Here's how project managers can ensure effective resource balance. 1. Regularly monitor resource utilization. Project managers should review team workloads, equipment usage, and budget consumption to identify inefficiencies. Tools like resource dashboards and time tracking software can provide real-time insights into how resources are being used. Example: construction resource monitoring. A construction manager regularly checks the availability of heavy machinery and skilled labor. If certain machines are being underutilized, adjustments are made to reassign them to high-priority tasks. 2. Adjust based on changing project needs. As projects evolve, resource needs shift. Unexpected challenges, client feedback, or external factors may require realigning resources. Example: software development adaptation. During a software project, new security vulnerabilities emerge that require urgent attention. Developers are temporarily reassigned to resolve these issues before continuing with their original tasks. 3. Maintain flexibility for resource reallocation. Project managers should plan for contingency resources, extra personnel, backup budgets, or alternative suppliers to address sudden changes. Example: manufacturing supply chain flexibility. A factory experiences a shortage of raw materials. Because an alternative supplier was pre-approved, the project continues with minimal delays. Common resource allocation challenges and solutions. Even with careful planning, projects encounter resource allocation challenges. Here are some common problems and strategies to address them. 1. Overallocation of resources. Issue: team members or equipment are assigned to too many tasks simultaneously. Solution: use resource leveling to distribute workload more evenly. 2. Unbalanced workload distribution. Issue: some team members are overloaded while others are underutilized. Solution: use resource smoothing to optimize workload across the team. 3. Unexpected resource shortages. Issue: a key team member is unavailable or a critical material is out of stock. Solution: maintain contingency resources and have backup plans. 4. Inflexible resource plans. Issue: resource allocation plans do not adapt to project changes. Solution: regularly review and adjust allocations based on project needs. Final thoughts. Effective resource allocation ensures that projects stay on schedule, meet deadlines, and operate efficiently. Whether through resource leveling, resource smoothing, or prioritization, project managers can balance workload and optimize resource usage. Key takeaways. Allocate resources strategically to critical tasks first. Continuously monitor workload distribution. Use resource leveling and smoothing to prevent burnout. Maintain flexibility for unexpected changes. In the next section, we will explore advanced scheduling techniques to further optimize project performance. No project goes exactly as planned, which is why buffer management and contingency planning are essential. Unforeseen circumstances, such as resource shortages, technical difficulties, or external disruptions, can impact project timelines. Proactively managing buffers and contingency plans ensures that teams stay on track and can handle challenges without derailing the entire project. Buffer management involves adding extra time, resources, or budget to absorb unexpected delays. These buffers act as a safeguard against uncertainties and provide flexibility when things do not go as scheduled. The key benefits of buffer management include preventing last-minute scrambling, enhancing schedule predictability, reducing the risk of failure, and improving resource efficiency. There are different types of buffers used in project management. One type is the project buffer, which is added at the end of the project timeline to account for overall uncertainties and potential overruns. This type of buffer ensures that if unforeseen delays occur, the final deadline is still achievable without causing a crisis. Another type is the feeding buffer, which is placed before a critical path task to prevent delays from non-critical path activities from affecting key tasks. This type of buffer helps to minimize the risk of disruptions from interdependent tasks. While buffer management helps in absorbing delays, contingency planning focuses on preparing for identified risks with specific action plans. It is about having a structured approach to handling risks by creating a backup plan when things go off track. Contingency planning minimizes disruptions, reduces downtime, enhances risk management, and boosts stakeholder confidence by ensuring the project is prepared for potential obstacles. Creating an effective contingency plan starts with identifying potential risks. Project teams must assess risks that are likely to occur and could impact the timeline, budget, or quality of the project. For example, in a construction project, risks might include weather delays, material shortages, or supplier issues. In an IT project, risks could include server failures, cybersecurity threats, or unexpected technical issues. By anticipating these risks, project managers can prepare strategies to mitigate their impact. After identifying potential risks, the next step is to assess their impact on the project. Some risks may cause minor disruptions, while others could delay the entire project by weeks or even months. Understanding the severity of risks allows teams to prioritize their contingency efforts. For instance, in a software development project, a minor coding error may take a few hours to fix, while a security vulnerability might delay a product launch by several weeks. Once risks have been identified and their potential impact assessed, teams need to develop response strategies. This means outlining specific actions to take when a risk materializes. If a supplier fails to deliver materials on time, the contingency plan might involve sourcing from an alternative supplier. If key personnel become unavailable, the plan could include cross-training team members to take over critical roles. Having predefined response strategies enables teams to act quickly rather than scramble for solutions when problems arise. Allocating contingency resources is another crucial step. It is not enough to have a plan in place. Teams must also ensure that the necessary resources are available. This might include setting aside emergency budget reserves, maintaining backup personnel, or securing alternative equipment. In event planning, for example, having a backup venue in case of last-minute cancellations is a practical contingency measure. In manufacturing, having pre-approved secondary suppliers can prevent delays caused by supply chain disruptions. One common mistake in buffer management is adding too much buffer time. While it is important to account for potential delays, excessive buffer time can lead to inefficiency and complacency. Teams may feel less urgency to complete tasks on schedule if they see that a large buffer is available. To avoid this, buffers should be calculated based on historical data, expert judgment, and realistic risk assessments. Another mistake is overlooking feeding buffers. When non-critical tasks cause delays that impact critical tasks, it can create hidden disruptions in the project timeline. By identifying dependencies and protecting key tasks with feeding buffers, project managers can ensure smoother workflows and avoid unexpected bottlenecks. Lack of predefined contingency plans is another common pitfall. Many teams fail to plan for potential risks and are forced to react on the spot when issues arise. This often results in delays, cost overruns, and mismanagement. To prevent this, project managers should proactively create response plans for the most likely risks before they occur. Ignoring resource allocation and contingency planning is another challenge. Some projects fail to secure backup personnel, funding, or tools, making it difficult to implement contingency measures when needed. Effective contingency planning requires teams to allocate the necessary resources in advance so that they can be deployed immediately if a risk occurs. Both buffer management and contingency planning play a critical role in project success. While buffer management absorbs the impact of unexpected delays, contingency planning ensures that the team has a structured approach to handling risks. Together, these strategies provide flexibility, reduce risks, and improve the overall stability of a project. To summarize, project managers should integrate buffer management and contingency planning into their project workflows. Adding appropriate buffers helps prevent unnecessary pressure and last-minute firefighting, while contingency planning ensures teams are prepared for risks before they happen. The combination of these strategies enables teams to handle uncertainties with confidence and keep projects on track. In the next section, we will explore advanced risk management techniques to further enhance project stability and resilience. Now, let's take a moment to reflect on real-world scheduling challenges. Even though this is a recorded session, you can still participate by thinking about your own experiences. Have you ever worked on a project where resource constraints led to delays? What were the biggest challenges you faced, and how did you navigate them? Think about times when you had overlapping deadlines or competing priorities. How did you manage to stay on track, and what methods did you find most effective? Some strategies work well, while others fall short. Based on your experience, what scheduling techniques have helped keep projects on schedule and which ones didn't work as expected. Feel free to jot down your thoughts or even share them in the comments if you're watching this on YouTube. Hearing different perspectives helps us learn practical approaches beyond just theory. Here are some best practices to keep in mind. Define clear roles and responsibilities. Ensure everyone knows their tasks and deadlines. Regularly update schedules. Project conditions change, and schedules should reflect current realities. Monitor resource usage. Keep track of resource allocation to prevent bottlenecks. Communicate proactively. Regular updates with the team help identify potential issues early. Use visual tools. Gantt charts, Kanban boards, or network diagrams can simplify complex schedules. The key takeaway is that effective scheduling and resource management are dynamic processes requiring continuous attention and adaptation. To summarize this section, understanding dependencies and milestones helps structure project schedules effectively. The critical path method identifies tasks that directly impact project timelines. Resource allocation strategies ensure efficient use of people and materials. Buffer management and contingency planning help manage risks proactively. Continuous monitoring and communication are crucial for successful project execution. Next, we'll dive into risk-based project planning to explore how to integrate risk management into your planning process.